Welcome back to another video on using PixInsight. Over the next few videos I'm going to look at processing a number of different types of deep sky object. In this first one, in part 8, we're going to look at the M3 globular cluster that we were processing earlier, and then in subsequent ones we'll look at deep sky objects such as narrowband false image, nebula, and maybe galaxies as well. Each of these will bring in a slightly different workflow as we discussed in the previous video, and also bring in some other techniques. So in general I'm not going to go over techniques that have already been described in an earlier video, but only go into detail on ones that haven't been explained in full in this particular application. So to start with, we're going to bring up our original image that we were working on before when we started to look at color calibration and deconvolution. And this is an automatic screen stretch of the stacked image before anything else happens to it. Now this is a screen stretched image which has got an equal stretch on each of the channels, which obviously amplifies all the light pollution. If I command click the stretch button, then it applies a different stretch to each of the channels and gives me an approximate image. But this isn't the one that we left off with in the previous video. So if I shrink that down and bring up this one, this is the cropped image, which if I apply a screen stretch to, is basically neutral, although if you look very carefully there is some color variation on it. And from this we use this tool up here to extract a luminance, and from the luminance we then deconvolved and did a bit of balancing on a luminance image. So if I bring up the luminance image from our previous exercise where we've done deconvolution, this has not been screen stretched, this is now permanent stretch, and you can see that the stars are much finer in this than in this one. So the trick is with this earlier image is to improve the color information, reduce the noise, and then use the color information from this image with the luminance information from this image to come up with the final image, which is this one. So that's what we're going to try and achieve in this video. Now in both cases I've actually got through to the final image, so I can scroll backwards and forwards through history to see what I've done, and it can be quite instructive. So in History Explorer, if I choose my luminance file, after taking the deconvolved one, I've basically stretched it using the Histogram transformation tool, and then done a mask stretch, and then done a little bit of noise reduction on the background. In the case of the colour one, I've done a little bit of noise reduction, I've changed the image name, I've done a bit of stretching, I've done some colour calibration, I've tweaked a few curves, which is probably saturation, and then I've combined it with the luminance. It's a fairly straightforward and simplistic workflow. Now there are a couple of things along the way where obviously I know what has worked because I've got to the final result, but along the way there's lots of experimentation, and I just wanted to contrast and compare some different techniques for achieving what seems to be the same process but produces a different result. But for now, let's shrink the History Explorer down and pretend we don't know anything. Let's clear the decks and start with the luminance. So this was the luminance file that we came out of the deconvolution process with, or more accurately, if I bring this back to here, this was the luminance file. And you can see the different steps that I've done in order to get it to where I want it to be. Now, if we just scroll back, the first couple of things we did was look at histogram transformations, in other words, to stretch the image. And one of the things I can show you from this, if I choose up the luminance file here, is drag the histogram tool here, and then if we double click it you can see precisely what I was doing to the file. So all I've done is drag the middle slider from the mid position to about here, and when you apply it to the image you get the result that you saw. But it doesn't really do a huge amount, it just starts to bring the very brightest stars to be more visible, it bloats the three bright stars a little bit more, but doesn't really get very far. When I repeat it with a slightly different value, I get a bit more information in the middle, and a few more of the fainter stars are starting to come out. And the second time round is building on the first time, obviously. Now in the history there's a third one, so if I click onto this one here, you can see that now it's got even brighter. But what's happening is some of these big stars are starting to grow quite large, and so the last stretch, to try and get the full extent of the globular cluster, I use something called masked stretch. A masked stretch, basically, if you notice that the middle part of the image doesn't really get any brighter, but the extended periphery does. If I had done that with a histogram transformation, if I now bring up the preview, obviously at the moment it's amplifying absolutely everything and it's making even the darks quite grey. So if I bring up the dark point and try and at least bring it onto the onset of darkness about there, you can see on the preview that the stars are very bloated now and don't have a particularly attractive appearance. So let's back up and take a look at a comparison between the techniques of stretching stars, because really this tutorial is about stretching stars more than anything else. So if I back up to the initial result of the deconvolution, and let's just take a small preview, and what I want to do is draw a preview which includes that bright star down the bottom and the core of the cluster, so we can compare results between the different stretching algorithms. I'm going to duplicate this preview so that I can contrast and compare the different stretching algorithms. So to do that, I'm going to click on the preview tab and drag it off. I can now get rid of this for the moment, just shrink it down and drag this off once and twice. Now what this will enable me to do is try out different combinations of the two stretching processes and contrast the effect. So the first one I'm going to look at is the histogram transformation. If I click on this one on the right hand side and click track and real-time preview, you can see the effect of applying a mid-slide stretch. If I apply that once and then twice, you can see that what I've got is a fairly reasonable stretch of the cluster in the middle plus the big bright star down the bottom. I'm going to apply this once to the middle one and leave it at that. And now what I'm going to do is look at masked stretch. Masked stretch works in a very different way. It differentially stretches an image depending on how bright it is. So the net effect is it stretches bright objects less than dim ones. And this is very useful for preventing stars bloating too significantly. If I hit the reset button down the bottom, it will go to the default parameters as you'd expect, but I might need to change the background value. So if I put my cursor on the background of the one I haven't played around with yet, the background value down the bottom, it says K 0.00015. So I'm going to put in 0.3 in as a background level and leave the rest at default parameters. This basically sets what the average background level will be after the stretch. This is the number of iterations it tries to stretch it, and this is a clipping function, which is when it sets the black point, how much of the blacks in terms of percentages is it going to actually remove and just truncate as pure black. Sometimes you get a much softer result by making this 0 so that it doesn't clip anything, but for most purposes this number will be quite good for an average well exposed scene. So I'm going to drag that to this third image on the left here, and you can immediately see that this stretch here, a single stretch here, has produced a much finer result with less brightening of the core than this one, which has less extent of the cluster. But it does have a few issues. If you look very closely at this little star down the bottom here, it's got a real peaky value, and if you look incredibly closely, you'll see it's got a few ringing artifacts. So one of the problems here is that masked stretch will create a spiky star as opposed to a bloaty star, but it can be overkill. So sometimes the best approach is to do a little of each. So in this middle one, I've done a mild stretch, and I'm going to now apply a masked stretch to it. And when you contrast and compare the results by going in close on each one. In these three images, this is the one that had mask stretch only, this was a combination, and this was histogram transformation only. You can see that the extent of the stars is very different in each one, and even in this mildly stretched one that doesn't show the less distinct stars, the stars themselves, whilst they're quite small at the moment, they already have quite bright centres that are quite extensive. And in these two, the star has a greater extent, but only the very central part of the star is pure white. And the reason for that is that these two have actually been stretched more effectively than this one. So really, to compare the processes, if I bring up histogram transformation again and just go a little bit further, so what I'm looking to do here is try and get the same level of detail in the stars. It'll only be approximate because it's almost impossible to match these things. Maybe something like that. So now if I look at this image here, you can see that, yes, you can see a similar number of stars as in these two, but now the stars have grown dramatically and are really rather large and white. So what we've done here is try to find a way of reducing the artifacts on the really bright stars, shrinking the size down as much as possible without clipping them, because as soon as you clip a star in terms of the white level, it doesn't matter how much colour information you have, it'll always just be a white blob. And if we scroll down to the bottom here with this really bright star, you can see that how much larger this one is compared to these two. Now these have issues. This one here, which was mask stretched only, has a number of ringing artifacts, dark and light. The one that was a combination has a slight darkening one, but to be honest, in later processes, when we do a little bit of sharpening and a few other processes, that will get sorted out. But thankfully, none of the other stars have that. The other thing to note in this particular case is if I go back to the whole image, you'll notice that when you look at the core of the cluster, that this is really rather bright now. And while the extent of the stars is about the same between the three images, these stars are much brighter and intense in their middle cores and to a fuller extent. One of the tricks you can do to reduce the clipping of a star is when you do the stretching is do not stretch without giving extra headroom. And that is done if you double click the histogram transformation tool. If I reset the parameters and say, for instance, in this particular one, if I just go back one step and in the high range here, extend the range a little bit by adding 10% of the range. And then when I do my stretch, if I stretch this image now, you'll notice that if I move this slider, I can dim the highlights down. So this is the opposite effect of dragging this slider downwards, which clips highlights. And you get the same thing in the levels output of Photoshop. So I typically apply a 10% headroom extension, and it remaps all the tones in between those new extents, basically before I do a stretch operation or any kind of sharpening operation, because both those operations increase local contrast, and if something's almost clipped, after stretching or making it sharper, it will almost certainly will be clipped. So I spend a lot of time making sure that I'm not ever getting to true white on the image, apart from the very extreme stars. So if I do that now and apply it, you'll see that yes, the core is better, it's not quite as bright in the middle, it hasn't reached clipping point, it's in the 80 to 90% range as opposed to the 90 to 100% range. And that's a useful trick to apply at certain points in any process. And in fact, quite often what I'll end up doing is just resetting all the parameters in the histogram transformation tool and simply putting that 1.1 in there and then dragging that tool to my desktop, shrinking that down, and then call this highlight protection. and then all I would do is when I'm just about to sharpen an image, I just drag it onto there, and it'll just add that little bit of extra headroom just to make things safe. So I think that's a good place to stop for a moment. I need a cup of tea because my throat's getting dry, and then when I return we'll look at the colour image. So we're back to where we started with a screen stretched colour image. The colour information is there, but it's very faint. So first of all, let's take the screen stretch off and let's look at the History Explorer to see what processes we're likely to apply to it. Now in here, this was a noise reduction process step which took noise out of all the smaller scale layers, because what I'm looking for at the end of this is a slightly soft but very colourful star image with no clipping at all. The next is to change the name of it, and then some stretching with the histogram transformation and the mask stretch tool, as we've just discovered, and then some colour calibration, and then some curves, which is a saturation boost, and then finally combining this image with the Luminance file. At the moment we're in the initial state here, so what I'm going to first of all do is look at the linear transform tool here. And this word multi-scale is something that strikes fear into a lot of people. So I've dragged all of these process icons out onto the desktop so we can take a look at them one by one. This tool, in effect, has the ability to boost or suppress or reduce noise in different parts of the image based on the scale of the structure. So very fine details are in small scales, and very broad details like big billowing clouds of gas are very large scales. And one way to visualize what a scale looks like is to use one of the scripts. And this script here under image analysis is called extract wavelet layers. And it's just one of those little useful utilities that can sometimes be quite handy. So if I go up to 6 layers and hit OK, it'll produce a series of images. And if I do a screen stretch on each one of these, you'll see that this is really blobby and very big. And as we go down the scales, they get less blobby and smaller still. And if this was a nebula, then clearly some of the fine tendrils of a nebula would be in the small scales, and the broad swathes of nebulosity would be in the larger scales. But you can see the general idea that as you go down the scales, so this is 1, 2, 4 pixels. So these are structures on a scale of about 4 pixels. And these are structures at a scale of about 2 pixels. And these are structures at a scale of 1 pixel. So you can see there's a lot of fine detail in this image, but I don't need that in this colour image. So in this process tool, I'm going to look at a number of structures up to 7 scales, and then the R here stands for residual layer, which is basically everything that's left. And these numbers here correspond to parameters that are set up in the dialogues down here. So for instance, if I change this one, you can see that that scale is changing, and if I select scale 2, that one's changing. So it's a useful way of doing a summary of each of the scales. And if I just very quickly go through them, the detail layer one, the bias, is just a simple emphasis and amplification of the image structures at that particular scale. And it's a common way of sharpening an image is by boosting it, not normally by very much, less than 10%. The other tool beneath it is a noise reduction tool, and it has 3 parameters. There's a threshold based on standard deviation units. The higher the threshold, the more aggressive the noise reduction. Then you have the amount of noise that it's removing, so 100% down to nothing. And then lastly, there is a number of iterations, so it can apply it and then look at what remains and apply it again. So typically you're most aggressive on the small scales, which is where most of the noise lies, and then less so as you go up the scales. And if you look here, the standard deviation numbers go 6, 5, 3, 2, 1, and that's quite a common sort of sequence of a starting point. And then likewise, the amount number, which is this one here, you can see that that's changing in the top. that would typically be 1, and then, you know, backing off to about a half by the time you get to the highest scale. And then the number of iterations. Now, there are 2 multi-scale tools. This is the linear one. There's also a median transform tool which works preferentially on stretched images. They are very similar in their layout with a couple of tiny differences, but they effectively work in the same way. This particular one can cause ringing if you're not careful, whereas the median one doesn't. And that only causes ringing when you're typically doing sharpening, not when you're doing noise reduction. Both of them also have something called a linear mask. And what the linear mask is it allows you to be selective about where you're either emphasizing or de-emphasizing or reducing noise based on the luminance value of the image. So for instance, if I just shrink this to give some visibility of it, if I hit linear mask and hit preview mask and then hit preview, it'll come up with a preview of the mask, and there's an inverted mask and a non-inverted one. Typically when you're sharpening something, you use this one, which is non-inverted, because you want to sharpen everything in white, which is an object. When you're doing noise reduction, you use an inverted mask, so that's protecting all the bright areas, and it'll do noise reduction on the background. And you can alter how much amplification you have to change the extent of the mask, and you can blur it slightly. Now, with a linear image, you will probably need a lot of amplification to get to the stars and the nebula, but when this image is stretched, you typically are using values of 1, 2 or 3 in the amplification, otherwise it just goes totally black. So if I stick it at 1000, it'll probably just go black. Oh, maybe not. Anyway, you get the general idea, but what this will do is preferentially reduce noise on areas where you want to reduce noise and not attack structures which you want to keep nice and defined. So I'm just going to cancel that for a second and bring down that preview and apply it. But what I'm doing before I apply it is doing a screen stretch, and I'm going to look at a small preview. So I'm going to apply it to that, and then it won't hopefully take too long. It does it for all the layers and all the channels because this is a colour image, so it takes a few seconds. And if I look at that, and if I toggle between the 2 states, you can see that the background has become nice and smooth. There is a little bit of mottling on it, but the stars have not been affected too much. So that's as much as I want to do. So what I can do now is I can apply it to the main image. And I'll come back in a few seconds when it's done it. Good. If I shrink that down, the next process and the following one are the 2 stretches. This is a very mild stretch for a histogram transformation, and if I remove the screen stretch and apply it, you'll see that it just produces a very small core, which you can see the colour starting to appear. And if I shrink that down and apply the masked stretch, so after a minute the masked stretch has done its job, and this is the end result, which is a soft globular cluster with some colour in the stars and no clipping other than maybe these few bright stars around the edge, but most importantly not in the core. The overall look is quite cool, and clusters are very ancient deep sky objects, and they normally consist more of old cooler stars than hot white ones, which tend to be bluer. So I've decided to do another fine-tune of the colour, and to do that with the colour calibration tool as we've used before, but this time I'm using 2 previews which selectively do the background here and some stars near the core. And this is the key one. This is the one that sets the white point. And if you notice, I've got quite a few blue stars in here. So hopefully by using these stars as references, it will try to even the balance between the warmer and the cooler stars and make the whole thing a little bit warmer. So when I hit apply, the overall result is just a tad warmer, which is more in keeping with the actual object in the sky. Now the next step is to improve the saturation, And the way I typically do that is not with the saturation tool, which is one that is used for selective colour saturation, but the curves transformation tool, which is another multi-purpose tool that allows you to do a number of things which changes intensity of different pixels. In this case, it's unlike colour saturation where you can selectively decrease the saturation of green pixels and increase red and blue and so forth. Curves transformation is more of a global application to the image. So if I bring it up, you'll see that yes, you have a curve here, but you have all these boxes along the bottom, and these respond to different types of stretching. So you can stretch red, green and blue just like you would do in a normal image. So for instance, clicking on the red channel, you can put an S curve in just as you could in Photoshop, or you can change the overall luminance of an image by putting an S curve or depressing it or making it brighter or whatever. You also have the same for LAB colour spaces, so you can do the colour difference channels or the luminance if that's how you prefer to do things. And if you are familiar with LAB, it's a very powerful technique as well. You can also selectively change the hue. So on hue, what it allows you to do is slightly shift hue or expand hue between different values, which can be quite useful to emphasize different parts of a nebula. And lastly, which is the tool we're going to use, is the S for saturation. And what this does is it selectively increases saturation depending on the existing colour differences in the file. So here, where the slope is greatest, is areas of low saturation are boosted more, and where the slope is shallowest is there's less increase in colour saturation. So I'm going to apply that to the image, and that should give me slightly warmer stars, as you can see there, and slightly cooler stars which are showing up as blue. So I've got a nice differential between the two different star types. And if I shut that down for a second, the last thing I want to do is now make that with the Luminance file to make the final image. So if I bring up the Luminance file, you can see the extent of this is far greater, the background's slightly lighter as well. That doesn't matter because all I'm worried about here is colour value. And the last tool I'm going to use is LRGB combination, which allows me to move the luminance information from here, combine it with the colour information from here. So it's under colour spaces. If I reset the tool, what you have is you can basically combine any number of channels together. In my case, I'm going to combine luminance with an existing image. So I'm going to pull up my luminance file, which is correct, and then simply drag it onto my colour image. So after a few seconds, that's now produced a colourful image that looks quite similar to this in terms of intensity, but it's picked up all the colour information. These sliders at the bottom allow you to modify the saturation and lightness of the end result. They work in reverse, so if you decrease the saturation one, it actually increases saturation values, and likewise if you decrease this, it actually makes things lighter. So these are very sensitive, these controls, but if you wanted to make a slightly more intense result, you'd perhaps do it like that and drop that on there, and it should be a little bit more intense in colour. Or if I want to make it slightly darker, like that. Again, it's all up to personal choice and experimentation, but I think you agree that that is a very pleasing image, and it has a lot of fine detail in it, which makes it quite interesting to look at, and a fascinating object to see through a telescope as well. So hopefully that's been useful. In the next one we're going to take a look at galaxies, and then the one following that will be nebula. And as I said in the beginning, I won't go through every tool every time. I'll go through the new tools I'm introducing in more detail than the ones that we've already played around with once or twice. Thank you for watching.